Hi everyone, welcome to this lecture. So in the previous lecture, we learned about the target values and the predicted values. We learned that when target values and predicted values are same, then there is no error and that situation is called an ideal situation. But in real situation, there is always an error. There are target values and predicted values for some samples or many samples which are different from each other. In that case, we need to calculate the value of error. Look at this target value. So this target value is far away from its predicted value. In that case, we need to calculate the error. Also in this figure, there are many data points which are a bit away from their predicted value. So for all those data points, we need to calculate the error. So this is the way of calculating the error. We need to subtract the predicted value from the target value, or we can also subtract target value from the predicted value. So error is basically the difference between the target value and the predicted value. Now error has been calculated. What is the next step? So next step is that we want to reduce this error in order to improve the performance of the regression model. Now, how to improve the performance or how to reduce this error? So suppose if the target value is 5 and the predicted value is 10, so the difference is 5. So with this simple value of 5, I cannot do anything. I cannot apply any algorithm or some mathematical method in order to reduce the error. So in order to reduce the error, we need to transform this error into a function. So the function in which we transform our error is known as cost function or loss function or objective function. So there are three common names which are used in literature. You can call it cost function, loss function, or objective function. Now, how to transform this error into a loss function or a cost function? So this cost function or loss function is known as mean square error, or in short MSE. Now this is the way of transforming error into a mean square error, which is the cost function for our regression analysis. Now that is our predicted value and this is target value. If I subtract them, I will get the error. So this error term is here. Then we are squaring this error term to make it square error. And then we are taking the mean by adding all the error and divided by the total number of sample in a data set. So this error or this loss function is known as mean square error. So we move in the reverse direction. In mean square error, error is the last word. So we calculate the error first, that is the target value minus predicted value. Then the second last word is square. Then we do squaring on the error. And then the first word is mean. So we will do it at the end. That is, we will calculate the mean by sum of all the square error and then divided by the total number of sample. So this is our mean square error. And this is the same figure which we use to understand the concept of the error. So in this way, we have transformed our error into a loss function or a cost function of a regression. Now this is a loss function. Now there is a square on it. I can easily take the derivative or I can apply any other method in order to reduce this loss function. So we cannot reduce our error directly. So in order to reduce the error, we transform the error into a loss function. So for regression, our loss function is mean square error. Now we have to reduce this loss function. So how to reduce this loss function? So in order to reduce this loss function, we have to use a least square method. So least square method is a method which is used to reduce this loss function. So in the next lecture, we will study how to use least square method to reduce the loss function of a regression. I will see you there in the next lecture.